Okay, back to the ranch. So we have our point of maximum downhill steepness, which is going to be the minimum here, and then it's going back to 0 here. Now, what happens? Well, it's going up positive here, and it stops right there. Now, what's the slope right here? I'd say that's 1 at the most. So we could continue that up to about 1. So right here is a slope of 1, and then it quits. Okay, so notice a couple of things. First point, when you're graphing a derivative from a function, you want to chart the zeros. Or, I'm sorry, chart the zeros of the derivative are the maxes and mins of the function. So where f of x has a max, you've got a 0. And notice the slope is going from positive to negative, which means your derivative goes from above the x-axis to below the x-axis, from positive to negative. Now here we've got a minimum, and this is where the slope is going from negative to positive. So notice we've got the derivative going from below to above the x-axis. And then here we've got from positive to negative again, so it goes from above to below, and then from negative to positive goes from below back to above again. So that's the very first thing you're going to do is get the relative maxes, relative mins charted as zeros on the derivative. Next thing you do is the points of inflection. Now the points of inflection are the points where it reaches maximum steepness. So this is going downhill, so this is maximum steepness downhill, which means a relative min on your derivative, because it's the greatest negative derivative. Then another point of inflection here, which is a relative max on your derivative, because it's the point of maximum positive slope. And then maximum negative slope again, and then the end point. Okay, now one other thing that you're going to find is whatever degree your original function is, your derivative will always be 1 less than that. So notice here's 1, 2, 3, 4 turns, so that makes this 5th degree. And we've got 1, 2, 3 turns, that makes this 4th degree. Anytime your original function, well, your derivative will always be 1 less degree than your original function. Okay, now there's one other important concept here. That is the derivative of the absolute value of x. So we've got f of x equals the absolute value of x. We want to find f prime of x. Now, obviously f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. We've memorized that. And f of x plus h is really the absolute value of x plus h minus f of x, which is absolute value of x, over h. Now, here's where the problem comes in. The function of the absolute value of x is really defined as x if x is greater than or equal to 0, and negative x if x is less than 0. Because if I have the absolute value of a negative number, then I have to make that negative number negative to make it positive. So that's what we have here. So our derivative is going to have 3 separate pieces to it. We're going to take the derivative when x is positive, when x is negative, and when x is 0. Okay, so when x is positive, then that means whatever the absolute value is, you just throw away the absolute value. So if x is positive, then the absolute value of x plus h is just x plus h. And the absolute value of x is just x. So this is when x is positive, just throw away absolute values and it's fine. So what do we have here? Well, this is going to be the limit as h approaches 0 of x plus h minus x, which is h over h. Well, the limit as h approaches 0 of h over h equals the limit as h approaches 0 of 1, which equals 1. Okay, now, on to our negative case. If x is less than 0, then the function is going to be the negative of whatever value we have. So, absolute value of x plus h becomes the negative quantity x plus h. And absolute value of x becomes negative x. Okay, so what I have here is the limit as h approaches 0 of negative x minus h, well, let's just write this out, negative x minus h plus x all over h, which equals the limit as h approaches 0 of negative h over h, which equals the limit as h approaches 0 of negative 1, which equals negative 1. All right, so what we see is, in our absolute value function, we have, on the positive side of it, the derivative is 1. On the negative side of it, the derivative is negative 1. Why is that? Well, let's check it out. If we use this concept right here, you know what, let's just get rid of it. Cut, take 2. Okay, my original function, f of x, is going to look like this. This is f of x equals absolute value of x. All right, now, what is my derivative going to look like? Well, we just said the slope here is negative 1. So that means here's 1, here's negative 1. Now this is a straight line. So the slope is constantly negative 1 with no curve. And the slope here is positive 1. And it's always positive 1. It never changes. It's not a curve. It's a straight line. So the slope is constant. Now, what is the slope right there at 0? Okay, we need to go back and check it out. Oops, wrong way. Cut, take 2. Okay. So, we said when x is positive, absolute value has a slope of 1. When x is negative, absolute value has a slope of negative 1. When x equals 0, what's going to happen? Well, we need to check out our left-hand limit and our right-hand limit. So, the right-hand limit, the limit as h approaches 0 from the right, equals f of x plus h, which is going to be the absolute value of x plus h, which we're making x 0, remember? So it becomes 0 plus h, minus the x, which is 0, all divided by h. So we have h over h, which equals 1. Now the left-hand limit is going to be 0 minus h, because we're on the left side, so h is negative, minus the x equals 0, all over h. Well, this becomes negative h over h, which is negative 1. So notice the right-hand limit is positive, the left-hand limit is negative. What does that tell you? If the left and the right-hand limits do not agree, the limit does not exist. Okay, so that means the derivative at x equals 0 does not exist. Notice, at anything positive, f prime equals 1. Anything negative, anything less than 0, f prime of x equals negative 1. But at 0, f prime of 0 does not exist. The other way you could think of it is, if the derivative is the slope at any point, so it's really the slope of the tangent, well, where's the tangent here? At 0. You don't even know. Like it could be 1, it could be negative 1, it could be anywhere in between. It does not exist. Okay, so where else do derivatives not exist? Well, the same thing happens if you have what's called a cusp. If you have a curve that goes like this. Okay, right at this point, f prime of x does not exist. This is called a cusp. And the derivative doesn't exist. Now, notice what's happening. If you take the slope of the tangent, it's getting steeper and steeper and steeper, and right at that point, it suddenly goes from positive to negative with nothing in between. So there's another situation where the left-hand limit is positive, the right-hand limit is negative, the limits, the left and right-hand limit do not agree, which means the limit does not exist, and if the limit doesn't exist, then the derivative, which is the limit, doesn't exist either. Now there's one other place where a derivative doesn't exist, and that's going to be where you have a vertical tangent. Okay, right here, that's a vertical tangent. F prime of x does not exist. Why? Because it would be negative infinity or positive infinity. So those are the places that your derivative does not exist. Okay, so the main thing for this section is, number one, you need to know the definition of derivative. That's most important. Number two, you need to recognize and be able to use all the other notations for derivative. Number three, you need to be able to take any function and give me the derivative using the definition of derivative, which means you're evaluating the limit as h approaches 0. And that includes polynomial function or a square root function or a rational function. There was an example in the book that we skipped. Example 5 on page 169 that's going to give you a rational function. You do the same thing. You're going to cancel h's and you're going to find a value. Now the final thing that you need to be able to do in this lesson is to be able to, wrong way. Yeah, to be able to, given a graph of a function, you need to be able to graph the derivative of that function, even when you don't have the equation of the function. Okay, that's it. Have fun with these.